Hi everyone, I'm Candela Solis. I'm a grad student here at Florida Tech. My major is mechanical engineering, and I'm the principal investigator of MATEAR, which stands for Moon Adapted Technology for Extraterrestrial Architectural Robotics. So the main goal of the project is to send this rover to the moon and start making bricks. So once we get there, we have the building blocks to make buildings, launch pads, so we can kind of have a head start once we get to the moon, because it's really costly, it's really challenging right now to start building there. So if we want to just send a rover or robot that it will do for us some work, and then we just kind of put it together, that will be a really advancing technology also that we could develop for future, for example, for Mars as well. We could do the same for Mars. So what we want to do, the main goal of the project is to start being ahead of the manufacturing on the moon. So the project is basically a rover. It's gonna do is extract regolith from the lunar surface. Regolith is kind of like the lunar soil. So it's gonna extract it, compact it, heat it up, and then dispose the bricks. So with those bricks, what we can do is mainly build moon bases, or we can even scale this project to Mars surface.
Hello, my name is Amiana Amata, and I am a senior in mechanical engineering, and I am a proud member of the MATEAR team. I was part of the thermal and power subsystem team for the MATEAR system, and this included working on the heating subsystem within the full system, which was our furnace. This consisted of an outside layer of aluminum casing, and it had ceramic fiber insulation located in the middle. And on the inner layer was a layer of castellite. And in this inner layer contained our heating coils, which are capable of heating our furnace to 1,000 degrees Celsius. The most exciting part of this project for me was building the entirety of the furnace. We spent many long days testing the furnace, and when we were finally able to create a brick with the furnace that we made ourselves, that was extremely fulfilling, and I believe that that was my favorite part of this entire project. I also loved working with my teams, or with my team members, regardless of the long nights. I love spending time with them, and I truly think that our team really came together in the end to build a product that we're all very proud of.
For my undergrad degree, I did astrobiology, and I have 3 minors, physics, chemistry, and biology. I would say that everything is possible, and nothing has to be just plant-based. You can go and do some other stuff. I know that astrobio is mainly just science, but then if you get a master's degree, like I'm doing in mechanical engineering, you can kind of fill that gap between the two type of academia, and build awesome projects like this. So my advice will be to don't think that nothing is possible. If you have a good idea, you should tell a professor and then start developing it from there. They're gonna hear you out, and they're gonna tell you if it's possible, if it's not. And even when we started building this project, we didn't know if it was even possible to make bricks with lunar regolith. I had that idea, and then it turns out that you can actually make those bricks. So nothing is impossible. If no one has done it so far, you can be the first one to actually do it.